Hi everyone, so here's your next ed puzzle video and it's on simplifying radicals. We briefly did this prior to us letting out of school, so hopefully some of it seems somewhat familiar to you. If not, we're starting from scratch. Okay, well, first of all, what is a radical expression? So let's break it down into its components. So the symbol here is called a radical sign or a root. Okay, it looks like a fancy looking check mark. And then the number underneath that symbol is called the radicand. And then you'll notice I have a line here, and I just put that there to bring your attention to this space because this is where an index will be. When there's not a number, it's understood to be 2. So the majority of the time, it is just 2, and we think of it like square root, breaking it down into 2 factors, the radicand. But sometimes there's a different number written here. So, for example, you've probably seen a 3 written in front of the radical sign before to indicate a cube root. Okay, all these things together create your radical expression. So all of them combined is your radical expression. And we're trying to figure out when is a radical expression in its simplest form. Okay, first criteria. The radicand cannot be divisible by a perfect square number, and 1 doesn't count. 1's a perfect square number, but we're not concerned if it's still divisible by 1. Okay, so this implies you need to know your perfect square numbers. Here's a list of the majority of the perfect square numbers you should have memorized, right? Because of our multiplication tables that we learned through 12. 12 times 12 being 144. Okay. Your second criteria is that the radicand cannot have a fraction in it. So you do not want a scenario like this, where you've got your radical sign or root and then the fraction underneath. That means you're not done simplifying that radical expression if that's the case. Okay, and then your third criteria is that there cannot be a radical sign or square root in the denominator of a fraction. And we're going to spend a little bit more time with that during your next class session. We're going to focus on your first criteria today. Okay, so how do I simplify radicals? Okay, previously you've had problems like this where you have the square root of a perfect square number. So the square root of 4 is 2 because 2 times 2 is equal to 4, right? 4 is a perfect square number. But now you're dealing with scenarios like this where you have the square root of 8, for example. 8 is not a perfect square number. Okay, so we ask ourselves, what are the factors of 8? Well, 4 and 2. We then take the square root of 4 and 2 and ask ourselves, is the square root of 4 and 2 such that the answers are whole numbers? In other words, can I solve these? Yes, the square root of 4 is 2, but the square root of 2, that's not a perfect square number either. However, it's only divisible by 1 in itself. Its only factors are 1 in itself. So we're just going to bring it down to the next line. So this little bit here is important for you to remember. If you have the square root of a prime number, like 2, you're going to leave it alone and bring it down to the next line of your solving. And that's because the factors of a prime number are 1 in itself. So you can't break it down any further. You're just going to have to leave it be. Your final answer for this example is 2 square roots of 2. That is the square root of 8 simplified. All right, so let's look at a couple more examples to get this kind of set into our brains. Let's say we want to simplify the radical, the square root of 125. Now, 125 is not a perfect square number, so I don't know the answer right off the bat. And the first thing I'm going to do is break it down into its factors. So 25 and 5, for example. What are the square roots of 25 and the square root of 5? Well, 25 is a perfect square number. I know the square root of 25 is 5 because 5 times 5 is 25. Now, the square root of 5 is a prime number, so I'm going to bring it down, leave it alone, and I'm done. So the square root of 125 simplified is 5 square root 5. And here's the steps that we need to kind of keep in our mind as we're going through this. You're asking yourself these questions. Is the radicand a perfect square number? If it's not, then we're going to look at its factors. And then we ask ourselves, can I take the square root of these factors? And then you're going to keep repeating these steps, these 3 steps. Is it a perfect square number? Can I take the square root of those factors? Okay, let's look at another example. The square root of 72. If I want to simplify this radical, I'm going to follow my steps. Is it a perfect square number? No. What are the factors of 72? I'm going to go with 24 and 3. Those are not the only factors, and we'll take a look at that in a second. I ask myself, can I take the square root of these numbers? No, they're not perfect square numbers. Now, 3 is a prime number, so I'm just going to bring down the square root of 3 in my next line, but then I need to break down 24 into its factors, 8 and 3, let's say. So what are the square roots of 8 and 3? Well, again, the square root of 3 is prime. I'm going to leave it be. And since the square root of 8 isn't prime, 8's not a prime number, nor is it a perfect square, I'm going to break it into its factors. Okay, so here's the factors of 8. And then you should have noticed, well, I have the square root of 3 repeated twice. Well, that's the same as squaring a number. A number multiplied by itself, that's an exponent of 2. Okay, so I've basically taken these 2 factors and written it as one, combined like terms, if you will. Okay, can I take the square root of 4? Can I take the square root of 2? The square root of 4 is a perfect square number. Its square root is 2. 2 is a prime number, so I'm going to leave it be. Now, these 2 operations, a square root and an exponent of 2, those are inverses. So they cancel each other out, and I'm left with 3. All right, so again, the square root of 4 is 2. The square root of 2 is prime. I'm going to leave it and bring it down. And then the square root and squaring a number are inverses, so that just results in 3. Okay? The next thing I'm going to do is just switch around my terms, associative property or commutative property. And 2 times 3 is 6. So 6 square root of 3 is your final answer. Right? A lot of work. You're probably thinking this is ridiculous. Okay, so let's look at the same problem from a different perspective. What if instead of 24 and 3, I had chosen the factors 8 and 9? What would have happened then? Okay, so I asked myself, what are the square roots of 8 and 9? 9 is a perfect square number. The square root of 9 is 3. 8 is not a perfect square number, so I'm breaking it down into its factors, 4 and 2. Okay, and then I'm going to take the square root of 4 and the square root of 2. Well, 4 is a perfect square number. Its answer is 2. The square root of 2 is prime. That radicand is prime, so I'm just bringing down that whole term. Now remember that 3 doesn't have the square root symbol anymore because we completed the square root of 9. Okay, and then combining like terms here, moving terms around, 2 times 3 is 6. So your final answer is the same. So regardless of what 2 factors you choose at the beginning, you should come to the same conclusion, 6 square root 2. Now, why was this so much easier when compared to my previous steps, or the same example solved in a different way? Well, here's why. You'll notice this factor is a perfect square number. Whereas when I first attempted the problem, I broke it down into 24 and 3. Neither of those are perfect square numbers. So it made the process longer. So if you can break down your radicand into at least one perfect square number, that is your best option, your most efficient option for solving. Okay? So I'd like for you to give solving or simplifying these radicals a try for yourself. Simplify the radical square root of 45. You should have got the result 3 square root 5. So you asked yourself, is it a perfect square number? Because if it was, that would be super easy. Fortunately, it's not, so you're going to break it down into its factors. You probably said 9 and 5, but that's not the only way you could solve this problem. You could have said 3 and 15, for example. So if I went with 9 and 5, I would take the square root of these. Are those answers whole numbers? Well, yeah, the square root of 9 is 3, but 5, this radicand is prime, so I'm going to leave it alone. Okay? How'd it go? Did you do a good job? Were you close? Let's go over one more example. Simplify the radical, the square root of 80. You should have got the answer 4 square root 5. Okay, so your first question is the radicand a perfect square number? No, 80 is not a perfect square, so we're going to have to break it into its factors. Let's say you went with the factors 8 and 10. Again, there's other factors. Regardless, you should still come to the same final conclusion for square root of 5. All right, so let's say if we went with 8 and 10, what are the square roots of 8 and 10, respectively? Well, neither 8 nor 10 are perfect square numbers, so unfortunately, I'm going to have to break those down into their factors. So 4 and 2, 2 and 5. And then I'm going to have to take the square root of all these factors. Okay. And then start simplifying from here. So I notice immediately that I have the square root of 2 repeated twice. Okay. So I'm going to combine those terms. I have the square root of 2 repeated twice. So that's an exponent of 2. Okay, and I've just brought down the square root of 5 and the square root of 4. The square root of 4 simplifies, it's a perfect square. The square root of 5 is a prime number, so I'm going to leave it alone. The square root and squaring are inverse operations, so they undo one another, and I'm left with 2. So 2 times 2 is 4. That's where my coefficient's coming from. And then the square root of 5. Okay, so hopefully you took some notes and attempted the practice questions. If you have any further questions about this video, please send me an email or a message via Remind. I'm going to be posting some more practice for you on simplifying radicals, so look for that on Google Classroom.